Hello, hello, how are you all? రాంబాబు సార్. రాంబాబు సార్.
హలో.
రాంబాబు సార్ వినిపిస్తుంది సార్.
సార్ క్లియర్ గానే ఉందా సార్?
క్లియర్ గానే ఉంది సార్. అయితే మనకి
యూట్యూబ్ లో లైవ్ వస్తుందా సార్?
లైవ్ వస్తుంది చూస్తున్నాను. అయితే ఇప్పుడు మనకి ఈ కెమెరాతో పనేం లేదు కదా రాంబాబు సార్?
సార్
ఈ కెమెరాతో పనేం ఉండదు కదా ఇంకా?
మన ఇక్కడ ఈ 360 డిగ్రీస్ కెమెరా తోట
మనకి ఇక్కడ స్క్రీన్ షేర్ చేయాల్సిన అవసరం లేదు. జస్ట్ ఇప్పుడు ప్రెజెంట్ అయితే గనక ఆ పోస్టర్ మనకి హోమ్ పేజ్ పోస్టర్ ఉంది కదా, అది డిస్‌ప్లే చేసేసేయండి.
అది ఎక్స్‌పోజ్ చేశాను సార్ ఇప్పుడు చూస్తున్నాను.
ఓకే. అయితే ఇంకొకటి ఇప్పుడు మనం చేయాల్సిందేంటంటే నా తేజ మేడం వాళ్ళు ఇప్పుడు పిల్లల్ని తీసుకొనొస్తారు. తేజ మేడం కూడా వస్తారు. అదే మోస్ట్‌లీ మీ దగ్గర నుంచి లాగిన్ అవుతారు కావచ్చు మేడం కూడా. అక్కడే ఇంట్రడక్షన్ ఇయన్నీ అయిపోతాయి మనకి. ఇంకా ఈ కెమెరాను ఆఫ్ చేసేసుకోవచ్చు.
తర్వాత కీనోడ్ స్టార్ట్ అయిన తర్వాత ఈ కెమెరా ఆఫ్ చేస్తాను. మైక్ కూడా ఆఫ్ చేస్తా సార్.
ఓకే. ఓకే. డన్ అయితే. ఓకే. అక్కడ బొకేస్, పాట్స్, వాటర్ బాటిల్స్ అన్నీ అక్కడ ఉన్నాయి కదండీ కార్నర్.
వాటర్ బాటిల్స్ కనపడలేదు సార్. నాకు బొకేస్, పాట్స్ ఉన్నాయి కానీ.
ఓకే. ఓకే.
వాటర్ బాటిల్స్ కనపడలేదు సార్.
సరే అయితే నేను వాటర్ బాటిల్స్ చెప్తానులే ఒకసారి మళ్ళీ ఒకసారి. ఓకే అన్న. థాంక్యూ. అయితే ఈ కెమెరాను ఆఫ్ చేసేసుకోవచ్చు మనకు కనిపించే కెమెరా.
ఆఫ్ చేసేస్తాలే సార్.
నైస్. సార్ యూట్యూబ్‌లో బ్లింక్ అవుతుంది చూడండి. ఏదో ఇష్యూ వస్తుంది. యూట్యూబ్ కంటిన్యూయస్‌గా బ్లింక్ అవుతుంది. ఓకే. నైస్.
వస్తుంది సార్ యూట్యూబ్‌లో.
हेलो सर। హలో
మేడం
వినిపిస్తుంది కదా?
వినిపిస్తుంది మేడం. మీకు క్లియర్గా వినిపిస్తుందా మేడం?
ఏంటి సార్?
మీకు క్లియర్గా వాయిస్ వినిపిస్తుందా మేడం?
యా బాగానే ఉంది. నేను ఒకసారి యూట్యూబ్ చెక్ చేస్తాను.
తిరుగుతూనే ఉంది కదా? తిరుగుతూనే ఉందబ్బా. తిరుగుతుందా? అవునా? ఒకసారి తేజ మ్యామ్ ఒకసారి మొబైల్లో చూడండి. ఇది కంటిన్యూస్ గా స్క్రీన్ తిరుగుతుంది. నా దగ్గర ఇష్యూవా లేకపోతే
ఎక్కడది?
యూట్యూబ్ లో?
యూట్యూబ్ నాకు
యూట్యూబ్
వచ్చింది. నా లిస్ట్లో వచ్చింది.
అంటే ఎట్లా వస్తుంది? నీట్ గా వస్తుందా అనేసి. ఆ. అంటే స్క్రీన్ కాన్స్టెంట్ గా ఉందా? స్క్రీన్ మూవ్ అవుతుందా?
కాన్స్టెంట్ ఉంది సార్.
కాన్స్టెంట్ నా దగ్గర ఇష్యూ ఉన్నట్టుంది. ఓకే, నా దగ్గర ఇష్యూ ఉన్నట్టుంది. నేను ఒకసారి అన్ని లాగౌట్ చేసి లాగిన్ చేస్తాను. కాన్స్టెంట్ గా ఉందా? నా దగ్గర ఇష్యూ ఉంది. నా పోస్టర్ ఫుల్ గా కనిపించట్లేదన్నా, కొంచెం ఒక కార్నర్ కనిపిస్తుంది.
సందీప్ సార్,
మేడం
మీరు ఫోన్ లో మాట్లాడండి, మ్యూట్ చేసి ఇదంతా లైవ్ లోకి వెళ్తుంది కన్వర్సేషన్. సార్ డౌన్లోడ్ చేసి ఓపెన్ చేయండి. Hello, sir. How are you?
Hello, how are you doing? I'm doing fine. Can you hear me well?
Yes, yes, we can hear you.
Great, thank you. Uh, how long is this talk?
45 minutes.
45 minutes. Okay, great.
So the students will not be joining using Google Meet. It is broadcasted using YouTube. They were seated in the seminar halls. So where the YouTube link
Okay.
is live streamed there. So through the same link, the students have any queries, they will be interacting with you after the session. Shall we start in 2 minutes, sir? Shall we wait? Is it okay for 2 minutes?
Yeah. So
Thank
can you share the screen?
you. Sure. So will you mail me the deck?
Yeah. Let me see how to share the full screen background. Fixed protocol. Okay, share screen. What's the hell?
Is there any issue with sharing the screen, sir?
Yeah. Share. So give me 1 second.
Sure, sure.
I need to fix this problem. Oh, so they don't allow Google Chrome. I already did. So what's the problem? Oh my God. Record this computer screen and audio. Grant access this application in private and security setting located in system setting. That's what I exactly did. So I don't know why they. So can you actually from your side share my screen?
Yeah, yeah, we can. So just share us the deck, sir. We will do it. So we will share our screen, your deck.
So let me send you the slide, okay?
Sure, sure.
Okay. And So how I send you through the chat? Because I don't normally I don't use this.
Yeah, you can mail me.
So email you, okay?
Email.
So it's from the ICACES. Is that okay?
It is okay.
2000,
Yeah.
2022, right?
Yes.
Okay. Um, so I already sent you that. Probably before you share the screen, I can start to talk, okay? Instead to for the student to wait, right? And then when you got my slide, you can start to share that slide, okay?
Sure, sir. So you mailed to ICACES 2022, right?
Yes, I do. Yeah. ICACES to 2022. From me is keynote August 7. Okay, great. Shall we start? Hello, can you hear me?
Yes, sir. We can hear you. Just give us 2 minutes, sir. We want to introduce you to the audience, to the students.
Okay.
Welcome all to the keynote session on Unifying Model, Data and Innovation Evaluation for Building Trustworthy Systems by June Harding. Junha Ding is inaugural Dean of the School of Computing, Professor of Computer Science, and Wyoming Excellence Chair at the University of Wyoming, where he began his appointment in fall 2026. Dr. Ding came to Wyoming from the University of North Texas, where he joined in 2018 as the first faculty member of the data science program and later served as inaugural chair of the Anuradha and Vikas Sinha Department of Data Science, building the department from the ground up. Under his leadership, the department launched its BS program, PhD program, substantially revised its undergraduate and graduate curricula, established the Sinha Data Innovation Lab, and was named UNT's Outstanding Academic Department in 2026. Before UNT, he spent 11 years on the computer science faculty at East Carolina University and earlier in his career worked 8 years in industry as a software engineer and project manager with Beckman Coulter and Johnson & Johnson. His research centers on software engineering, machine learning, and AI, and data science, with particular interest in how computation, data science, and AI together enable discovery across scientific and applied disciplines. We welcome you, sir. Over to you, sir.
Thank you. Thank you for your introduction. Okay. And today I'm going to talk about our work on the unified model and data for building trustworthy systems. We focus on intelligent system and then how to validate the intelligent system. So we will talk about first about the gap between software testing right now to for the AI testing, um, and then we will talk some about discuss the method we used or explore and to conduct the AI testing. And then because the AI testing has a particular character that is data driven, so we will discuss how the data quality impact the validation of the AI system. And then finally, I talk about our recently work on prompt validation as well as some agent AI work on quality assurance. Now, so one of the fundamental challenge of soft testing is maximizing useful scenario coverage while minimizing test cost. In other words, we want to test as more as possible cases, and then we also want to reduce the cost. Right? You don't want to exhaustively to cover all the scenario at the same time. In many cases, that's impossible and not necessary. Right? So we want to using representative test cases to cover the possibility of the different scenarios. That's the goal. Now, there are many different testing, including non-functional testing and functional testing, basically, such as security is non-functional, right? Some of the performance testing non-functional. But here, what we focus on is functional testing, and particularly on neural network model or deep learning models. Now, we are not actually talking about related to specific about implementation of the AI model. For example, you have the CNN model you implement, and then we can test how this model self is being implemented, such as the active function. This type of stuff actually is will implement or correctly implement, right? The each layer actually be implement the connection of all of these implement correctly. Now, that is a typical software testing research. What we focus on is about the model self after model training, right? Including the model actually trained, whether this model actually work as we expected. For example, we have a CNN model to do the classification. If we say this actually can do classification of objects, how we sure this trained model actually can validate, can correct, classify different objects? Can they? Right? We say, okay, so far that's good, but it can be generalized to all kinds of objects. Right? In many cases, we can get some degree of the generalization, but not all. Right? Because that's why we need to refine that, and then performance. But how about the regression? Right? The regression. That means this may work pretty well on this case, but not necessary to work on other cases. Right? So, how we issue this system after fine tune or transfer learning or trained that still not regraded, right? Not regraded. So that's what we are focused on. The research I'm talking about. That's also the interesting work we want to do. So here is what the next slide. How to test an AI model. It's AI model. It's implemented model self. Okay, next slide is. So here is two questions. How to define the test coverage, right? When we test not prove. So we have, in other words, we want to test it's good enough, right? Adequate, not actually prove 100% is bug-free or error-free. So how are we actually to say this model self are well tested or adequately tested? How to define the test coverage or requirement? There are plenty, such as can we do the input corresponding to the output, and then to use that to define this the coverage. In many cases, that might not work. The second question is, what are the test adequacy criteria? Right? First, how to define, and then we summarize a criteria to do that. That might be a big question right now. Now, what we're doing here is, now, next slide is how to test a model. We have some observation. Doesn't mean we actually already solved this problem. It's just that we have a little bit observation here. Observation one: the training data is important to the performance of the data-centric AI models. Garbage in, garbage out. Everybody know that, right? So we may need to define the coverage or define the coverage or define the criteria based on the data quality. The observation two is the test dataset may not able to measure the true performance of the model due to the low quality of the dataset. So if you appear just based on the benchmark, right? This everybody agree. We use this benchmark. How to actually the benchmark work? Right. Nowadays, every several days, right? You say, okay, this model actually pretty good on other, and everybody claim they win, right? And not necessary, right? Because the benchmark has lots of defects as well. So, okay. And that's the result can be used to refine the AI model. When we do testing, right? When we do testing in the software testing, what do we do? Test. We want to find it. Bug, find the error. Right. We find the problem. We find that this a crash or something like that, and then we track. We need to debug it, right? And that actually is indirectly improve our system quality. Right? So you fix the problem. Same for this generative AI system or AI system. We're also using the test results to improve our system. That's what we actually, our research work, and try to focus on how actually the test results, right, including the test process, can be feedback to the model to help the model to improve. Now here we introduce one of the technique we call it metamorphic testing for test the AI model. Metamorphic phase testing has a very simple idea. It's originally to try to solve the non-TESCO oracle problem. Okay, non-test Oracle problem. So here is just say, okay, some system, right? If they say, okay, very, very complex scientific calculation. Now we implement, we do this, but we don't know that, right? We give a complex input and we get output. We don't know actually it's correct. If we already know, we don't need to build this system, right? The build system is trying to calculate. So this type of, but should we test it? Of course, we need to test it. We test it, we maybe use it called metamorphic. That means we don't know exactly output will be, but we give two input, they are related, and we know the corresponding output how related. And we check that relation. So in other words, we lose a little bit the test oracle. Losing a little bit test oracle to test the system in some degree. Not 100%, not ideally, but so we can use this kind of idea to test the system. Is pretty complex. So here is one of the example. Next slide is testing a cell image classification. This is the system we built. We built actually using the flow cytomic example is just a ladder to inject the cell and generate the scatter image. Right. So we scatter signal and we capture as image, and using this scatter image to try to classify the cell type. Right. So basically for white blood cell, okay, 5 different kind of white blood cell, and we want to use this image to do this. Now, in order to do this, we build a CNN model. Next slide. So this is a cell classification of individual cell based on that, right? So we get a CNN, and then we try to do that. And then when we do the training this, we don't really have sufficient amount of the image to train the model to achieve that performance. Then what we need to do is we get actually something is called a scientific model to model that model. Okay. So next, so cell image generation, right? So we're using a scientific modeling to generate that image. That of course that image generate not real image, so it's much more looks perfect or artificial compared. But they have some specific. They capture the main feature. That's what we talk about metamorphic. Right? There's a feature we throw tweak a little bit this input, and we know, right, when we change them in relation, this will become a different, right? Or this, it shouldn't be this white blood cell anymore. Or you should not change the white blood cell. So we through this manipulate the input, we can generate lots of image. And this image will be input to that, right? We through say, okay, this is a type A, this is not type A, this is right, and it's type B, this is not type B, whatever, right? So we have, let's say, 5 parameters. They can change each parameters. They can change some range. You know, the combination will be lots, right? We can generate lots of image and use this idea, and then we using this called few shot technique, right? We added a little bit input image, and then to see the classification will improve not, right? So this idea we will talk about next slide. Next slide, okay? So we use this testing to test this the cell classification, and then we actually build pretty large of the high quality cell classification data, and to do this type of analysis, and we also to experiment metamorphic testing to test the quality of the model. Oh, okay, now the next question, next slide. But now here is how we actually sure that generate, we know that data actually now improve the quality of the classification, but can we actually improve a little bit, say this technique can be generalized or not? Right, so we talk about since that time, 2017, right, almost 10 years ago, we tried to integrate the data quality into the software testing, AI testing. So we have to define something called data quality. So are data sufficient for training and testing the AI model? Right? We define the quality and then based on accuracy. Yeah, yes, please, next, yeah. Accuracy, completeness, representative, timeliness, by fairness, and label quality. This not necessary to be systematically to define the quality of data. It's just representative data, and we believe that's good enough to issue the data quality for CNN model training. Okay, so next. Now, but they're also right. We observe that data have data quality problems such as label lossy and inaccurate data bias, representative and gaps, concept drifting, and domain shift, and also lots of problems. Next slide. So yeah. So now, the next slide, please. Next slide. Okay. So how we evaluate? How to evaluate that? Okay, we actually here has a one of the example. Now we this fortunately I that time I came to the UNT and then University of North Texas, and then we read some paper that time. We find they working on something. This actually published in the ACL, right? One of the top conference in computation linguistics. So that idea is here. Say the paper say, okay, they do this called it concept mapping. So it's the medical concept mapping is just the normalization. They say people in the social media, when we talk about someone we feel uncomfortable health issue, we use non medical or scientific term. Instead, we use plain text. We use in layman term. Now, in order to do lots of the data mining work or understanding, we need to mapping the the informal term to the formal medical concept. That's the idea. We automatically to mapping this. So the paper published say this is a huge difficult problem, right? Because the informal, there's so many different cases, and sometimes they also a vague issue, right? It's a big problem. Okay, so now they try to they publish paper, they use CNN, they use say they claim, okay, my God, my result now is better than the that is best work, double in accuracy. That's crazy, right? But we check that without, hey, what's the problem? They didn't use any new stuff. Nothing is new. Just so how they can achieve this best performance? It doesn't make any sense. Of course, the CNN that time, the deep learning CNN that time is not very, especially for large amount of the data. There's not very widely used yet. But anyway, right, in the field, people still understand that pretty well. So anyway, the problem is I make this simple. So I have lots of slides here. If you're interested in read, but I can summarize in very simple ways. The problem is due to the test data set is overlap to the training data. That's one thing. Test data quality is bad, right? They actually can cause lots of the overfitting issue. The second is the training data itself has a problem. The training data actually have many of this medical concept, the formal concept, don't have an informal mapping. Okay, informal mapping. Of course, some informal mapping phase also don't have formal concept there. So there are also lots of the then just incomplete pair and use it. And when they actually try to count the accuracy when you have nothing mapped, they just automatically believe it's correct. So that's why they actually the result is, I don't know how this paper actually published, but it published, okay, and published in ACL. So we did the experiment and then we do some testing. Next slide. And then we know this has a problem, so we evaluate the quality of the data and then we do experiments. So how about we remove this type of redundancy or overlap between the training data and the testing data? We show that the performance increase, the accuracy increase is positively associated with the overlap. That means it's all fitting, right? No doubt it. It's very simple. Yeah, this slide very good to show that. Okay, but of course they suffer all other issues. Next slide. So this we do some of this testing based on this the overlap degree. Okay, so next slide. So here we show that this, okay, we observe that is the training data and the testing that both contribute the error or the overclaim of this the research work. Okay, next slide. Now, how we improve it? This is a problem, but if we do just on the data itself, can we actually improve the training data quality and testing quality to improve the accuracy? Of course, we can, right? The idea is, okay, how about we collect more data? And the general idea is correct. But here I just summarize the idea is, we did lots of experiments to show we do fine tuning here. We don't really from scratch to train the data using all this data, but instead we use fine tuning. That means you fix most of the layer of the model and then try to just to retrain the last layer or the first layer, whatever, to improve the performance. That's the fine tuning model we talk about. And we also use transfer learning. So now, if you just simply added new data into it, right, the mapping, it's not necessary to improve the performance very well, okay? But why? Because if you have one kind of disease, and you only talk about this kind of disease, and you added this data related to this disease, but then you talk about very different informal, right, and disease. It's when you talk about cancer or something like that, this blah 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 blah, and then you talk about everything about, okay, the depression, right, something like that, okay, mental issue or something like that. The domain non-related, maybe not really can be transferred, that scaling, right, not actually to apply to the new data. So if you want to be good, you still need that related domain. So now the question is, so next slide. So this experiment just to show that I need all of this result here. So if you're interested, I don't mind to share this slide with you guys, but right, we due to the time, we don't want to explain all of these experiment details. Okay, next slide. So yeah, go ahead, go next. So the idea here is how we actually can improve the data quality. In addition, just collect more data or collect related domain data. Can we actually generate a huge amount of data, right? That time or GPT already pretty good. So next slide, what we want to do, can we really generate artificial informal term mapping to the correct or mapping to the formal phases? Of course, this idea now is pretty simple, but
how we act, because the GPT they generate, we don't really believe it, right? So actually we did some of the using human being expert to evaluate all of this. And then separate evaluation, we actually calculate the consistent using, right, the kappa value. You guys know that, right? And then we have, if the kappa value is pretty agree, and then we say, okay, this might, because informal and to formal, that's still lots of the value, right? It's not 100% as mathematics. Okay, right? Different people maybe have different opinion, but we only choose that agreement is very high, and then we use it. Anyway, so we use this actually to generate, we generate lots of data. Next slide. And unfortunately, next slide, please. So yeah. Next slide. So we have the preparation and we generate, and the we use this generate data and to do the model evaluation, a different kind of model. We find it's pretty interesting. It's not really improve the performance as we expected, right? Not actually. Why? Why we generate this so many data actually did not really increase the performance as we expect. It increased a little bit, but maybe not actually what we the much. Okay, not much. There have two things here. Go next. Please, next slide. So one thing is, they're the testing data set. Actually, we're still using original testing set. They have lots of these incomplete pair. So incomplete pair originally, right? They say, I have failed dizzy, and then you consider that a cancer, okay? Right? Something I just this is just an example, okay? But if they are cancer originally, or in no paired, right? There, because there are so many incomplete. And then whatever you give, they consider as correct. But now we actually generate, we actually build that collection, say you have to map into that exactly mapping, right? If you mapping incorrect, if you mapping is empty, then not counts. So there actually is, right, it's not really performance reduced, it's because unfair evaluate by the previous experiment. So that's one observation. Another actually, we find when we generate that, we give the prompt and let them to random generate. And there's actually the model self, because the model also trained by much of these data. So they generate very easily to generate similar data like before. Okay. They don't really generate a new pair, very new pair. So here what we're doing here is, well, this is just a guess, hypothesis, right? So what we're doing here is, okay, we try to see the similarity of the generate data set and that originally organic data set, to see if these two sets are very similar. So what we do, the pair, right? The pair, and what we're doing here is the pair, the vector of this informal and vector of this the concept, and they have this vector has cosine difference. So we calculate that difference, right, for each sample, and then we average that. So we get the average similarity on this data set. And then we generate lots of this, right? We can bootstrapping and then generate the distribution. And we will see that distribution very similar. What we're talking about here, lots of the slide is about this actually bootstrapping and then calculus similarity. And then we compare this basically like right A/B testing. And through this A/B testing, we will see that generates right. Of course, we focus on same this formal medical concept, and we will see the generate if we don't manipulate our prompt, and this will be very similar. That means you don't really generate the new training data. Okay, for that, even you prompt, you generate original. If you see that a lot of the complete, but they not really improve much. So we want to expand that concept. Right. Instead, you only focus on this 20 of something, or 20 of informal to that. And can we actually have lots of even typo, even dilate, right, or social media of different age? The originally you maybe collect the data actually from 20 years old to 30 years old, and then we generate you maybe actually just 18 to 35 or something like that. But can we actually have more the data actually talk about by people from 60 to 90? That's the idea. That's the idea to generate more data to improve the data quality. Actually, we call it representative. The sample, right? This is it's kind of, if you're from statistics, you know this is just a simple sampling technique, right? So we want sampling to be more representative, right? To be more confident. But nowadays, if we look at that training data, actually anybody can say, okay, well, how much of the confidence we have. No, that's just whatever. We get collected, we put on and we train it, and we thought pretty good, and actually always suffer some kind of problem, right? But if we really want to improve, we need to look at our data even more carefully. Okay, so next. So that's the idea. Okay, so quality evaluation we talk about here, and then I don't want to cover these details, but the basic idea I already covered it. I hopefully this actually, the everything you read here will be extremely easy. Okay, next slide, please. Hello. Okay, go ahead. Lots of the, yeah, this is similarity we talk about. This is basically this A/B testing we did for. We look at that the closing, right? How close this generate and non-generate some the original data set. Okay, go more and this. Okay, and we do some different manipulation of the prompting, and then we get the similarity will be right. We will be get the more. Actually the distribution will be the diversity deviation will be larger, and then we okay the quality actually improve. Okay, go ahead. Go. Yeah, so this is the details. I don't want to talk much about the information. Maybe you are interested to that. Go ahead. So we expect. What kind of security do you really need? Right. So all of these questions need to be answered as early as possible. So can we actually using a formal method and to specify the system, and then using the formal method and to generate code? The idea is actually what experiment is not, right? That doesn't work. If you generate, they say we use a mathematical model, and then using mathematical model as a prompt to generate code, and that looks perfect, right? But unfortunately, LLM doesn't really understand the formal specification. It doesn't work. So what we need to do is we actually just formal verify or formal validate the specification itself, and then to see if there any problem. If there any problem, and then we need to catch as possible as early as possible. And then we still use natural language prompt to generate the system. And then we generate system, and then we may actually extract that model, formal model, and then use a formal verification to verify the model and to see that actually the system correct or not. That's the idea. So another thing is what we're doing actually is agentic. So this is the best we conduct some experiment on the dining philosophy problem. Okay, this is very simple problem, so I don't want to. Another idea what we're doing here is agentic. So in the agentic, right, we have this solving the problem. We don't have slide here, but I just using a couple of minutes to cover that. So agentic, we're using agent to solve the problem at the right. We can reuse, because the problem solving is a sequence. When we have this sequence, right, we need to reuse the information we used. And the previous information we need to store in the memory, and then later on our agent can reuse it. That's the idea. Right? So we actually, when we save this, then we retrieve this using token. The more token, the more cost, and the more memory. So how we reduce it? So instead, because all of this knowledge you use, right, or task solving in the agentic can be converted, you represent as text, but we can convert into the image. That actually is the work published about last year by DeepSeek from China. So we use this idea actually to convert this subtask text into image, and then embedded image, because when you embedding that text, every word will have one token, right? Because embedding. So, but in image, we can use much small. So you have a page, right? If you have a page, then we can use 512 times 512 pixel to represent that. And then we probably only, instead using, right, 1000 token, now I only use 100 token. So it's about 10 times reduced. And then of course, that corresponding text has to be stored in the storage. And then later on, if we really need it, and then we use that the embedded image embedded the token to retrieve that externally stored the text, and then to recover that text, and then to reuse. That's an idea. We try to reduce the cost in the memory, and then still can achieve the same performance as before. But of course, the time spending on this type of inferring is much longer than you just directly work on the word embedding or word talking in agentic. Right? That's idea that we recently published, and in the ACL 2026 is related to that topic, because I didn't prepare a slide for that, so I want to share something the work with you guys that will be work on similar on this data and model work to validate the software system or improve the software or intelligences, the trustworthy. Okay, I believe I already run out of time. So thank you very much. If you have, do you have any question? Okay, if you don't have a question, thank you everybody, and thanks give me this opportunity to talking with everybody, and I hope I have other opportunity to work with everybody. And for students, if you're interested to study in the University of Wyoming, please let me know or directly apply. University of Wyoming here now we have a fantastic summer, and also the tuition is very reasonable and the quality pretty high, right? So same as quality as University of North Texas, but of course the University of North Texas in the Dallas area is a fantastic metropolitan area, lots of opportunity. But the University of Wyoming in a remote area, but very close to Denver, and then right you can focus on study here during study, and then you looking for opportunity maybe in Denver area or other Western. I don't think that there any problem. Okay, so there are many different choice. So if you need my help, let me know. Okay, thank you.
Thank you so much, sir.
Thank you.
If the students want to interact with you, I will share your email ID with them, sir. So they will
Sure. Yeah.
keep in touch with you.
Yeah.
Thank you, sir. Shall we end the session?
Yep. Thank you very much, and have a good conference. And thanks for having me here. Okay.
Okay. Rambabu, sir, we shall close the session now.
Afternoon. ಕ್ಲಾಸ್ಗೆ ಅಲ್ಲ ನಮ್ಮ ಕ್ಲಾಸ್ ಅಂತ ಕ್ಲಾಸ್ మళ్ళీ వెనకాల మళ్ళీ